Thank you very much indeed. I see Martin Rees has shown up already. Hi, Martin. So because it's very important you are here, because the last slide is on you, actually. That's very good, but we have you here. Yeah, thanks a lot. Very nice to be back to Cambridge and to Trinity College here. I will talk clearly about the climate challenge, and some of you may have seen the movie 2001, one of the best films ever made. And yeah, and this is just turning around the number 1 and then ask, where will we go and what will we know about our Odyssey in climate space in the year 2100? By then we will probably know where spaceship Earth is heading for, but then it will be too late to change the course. So I will talk on the one hand about the problem clearly of climate change and how this is to be seen in geological time, because now we are about to become such a powerful geological force on Earth that we can really change the course of this planet in geological time. The question is, how far will we push the Earth back? 1 million years, 50 million years, 60 million years? And will give you the answer to the best of my current knowledge, of course. But then the second part of the talk will clearly be on what can we do about it. And you know, I've harvested a lot of experiences in dealing with decision makers. I just come back actually last weekend. It was the Munich Security Conference, and it is actually the most important meeting in the whole year where the really powerful people come together and talk about security. That means, you know, rockets, warheads, armies, battleships and things like that. But for the first time on Saturday, we had a session on climate change as a geopolitical risk, and I had the pleasure to give the keynote. And this is a game-changing thing, actually. But in the world of the really mighty and rich, climate change figures as an existential risk, really. So times are changing. The problem is, will they see enough change in policy making? And I will not allude much to what is going on in this country, because in a way it's great fun to watch it from the continent, but it's a dead serious issue, clearly, because, and I really thought with a little bit of sentimental feelings, is this the last time when I come here as a European to Europeans, so to speak? Really, I mean, it's a bit sad to think about that. I mean, still, Britain will be part of Europe, clearly, in geographical terms, but the European Union is, among many bad experiments, certainly the best. And yeah, I hope very much, and I think the mood here in Cambridge is similar. I hope somehow we will stay together. But let's talk about the climate issue first. So let me see. I start with some mundane little information which you all know in a way, but you can simply step out of this room. It's a balmy Mediterranean night on the 20th of February or 21st of February. So things are changing, everybody can feel it. This is, you know, because of the shutdown of the US government, we had to use the Berkeley Earth surface temperature sort of data to just look at global mean temperature rise, you see, since 1860 reconstructed. And of course, it's a wiggly line like all physical variables, but the trend is absolutely clear. And the probability that 4 years in a row in an equilibrium statistical ensemble would all be above the years before is 1 in 10 million or something. So the Earth is warming beyond any doubt, really. Global warming, so we had last year, the IPCC had an impossible task given in Paris in 2015 when the Paris Agreement was settled, namely come up with a report on why 1.5 degrees is a better guardrail than 2 degrees. Okay, this can be done to some extent. So you should tell this was the right choice made in Paris, but then you should also tell people that it is more or less just a walk in the park to actually keep global warming below 1.5 degrees. And I'll refer to that a little bit. And somehow the IPCC came up actually with precisely what was expected from them, namely, yes, 1.5 and 2 degrees, that's a hell of a difference in terms of impacts. And yes, we can still hold that line, but of course only if we have massive negative emissions, and I'll come to that a little bit later. I think this is a very dangerous road, actually. But when you talk about, so just take the time to look at this cartoon. I mean, this is precisely how I feel. I have been in this business for 30 years now, and Martin has been in this business even longer. And somehow this is precisely, so the world is sleeping, the alarm goes off, IPCC, another alarm, and what do? You just crash it, crush it, and that's it, and you keep on sleeping, clearly. It's not entirely true, though. In particular, last year, something has changed. This is now, I showed this also at the Munich Security Conference. The Pew Research Center has just published, they polled 27,000 individuals in 26 countries of the world. And this is the result, what is the top global threat last year. And you see everywhere where it's gray, I mean, the color is a little bit different here on this projection. In gray, that is, the number one is climate change. And you have in the US, for example, the fear of cyber attacks from other countries is bigger. But in most countries, it's actually climate change on all 5 continents, by the way. And when you have Islamic militant groups, clearly in Indonesia, wherever you have Islamic minorities, this clearly is a big threat. Nigeria, Boko Haram, and so on. There's just one country that sticks out, Poland, where the number one threat is still Russia, so to speak. So they are not afraid of global warming or cyberspace war or things like that, just afraid of Russia. But otherwise, you clearly see it's the number one threat. And this clearly has to do with experiences we made in 2017, Puerto Rico, Hurricane Maria, probably 3,000 to 5,000 deaths, and clearly the devastating wildfires in California. You have seen all that. I mean, the interesting thing, where I lived in California for a while, and so I really know the place. I mean, what happened here in this city called Paradise? I mean, people were caught asleep, actually, by the firestorm, which spread with a velocity of 60 miles per hour. And you have no chance to escape. You have no chance whatsoever. This was in the middle of the night, just rushed across the city and destroyed everything. And it came out of the blue, clearly. So it's not that with a little bit better fire management, as President Trump sort of mentioned, you could solve that problem. These are non-manageable extreme events. They either happen and when you're just dead, or they can be avoided, at least the probability, and that again has to do with climate mitigation. Now in Germany, and I don't know how the weather really was in the UK last year, but in Germany we had this big drought. Actually, it was the warmest year on record. It was one of the driest years on record. The soil moisture is absolutely at a historical minimum. And then people really started to wake up and to think about it. So if you live in Berlin in a sort of loft and the temperature, even during the night, doesn't go below 32 degrees when it becomes uncomfortable, actually. Yeah? But so the farmers in particular, they had tremendous losses and wanted compensation and so on. So people really woke up, and we have now a new debate. Now, it was mentioned already, my work on tipping points and tipping elements. Now, what happened last year is actually directly related to climate change, not because the planet gets warmer, you know. So from a thermodynamical point of view, of course, you have more heat waves and so on. No, this is the dynamics of the atmosphere. The circulation patterns will change. And from a point of view of physics, what's much more interesting, of course. So let me see here. So this is, you may have seen this sort of animation of the jet stream, the so-called jet stream. So this ribbon of high velocity wind, 10 to 12 kilometers above ground. And this is separating Arctic cool air from temperate air, clearly. And it's driven precisely by the gradient, by the temperature difference. And it goes from west to east because of the rotation of the Earth and so on. We can explain all that. Now, the interesting thing is that over the last decades, this jet stream has become more wiggly, actually. So it's forming huge sort of bulges towards the south or the north. And these so-called Rossby waves, they stay put, actually, for 6 weeks. So what happened, for example, in 2010 was this dual, if you like, extreme event where the jet stream had this northward bulge across Moscow. So in Russia, you had this terrible heat wave. But on the back of it, there was this southward bulge, because in the end, momentum has to be preserved. And you had this biblical floods in Pakistan. And we clearly saw in our data, but also in the wave equations, that this is going to happen more often in the future. And it's really interesting that, so I recall very well, because at that time I was living here in the UK and as research director of the Tyndall Center, and we tried to publish our findings. So it was really departing from the wave equations. There are ugly nonlinear terms in it. You have to deal with them. And we really made this observation that with global warming, in particular because the Arctic is warming 3 times as fast as the rest of the planet, so the temperature difference becomes smaller, but you have to look really into wave resonance and ugly things, physical things. But the upshot was, the bottom line was, Rossby waves will become bigger and they will become more stationary in the future. And then, of course, you are prone for extreme events. So we tried to publish this, and of course, as a natural scientist, you first send it to Nature, and it was rejected immediately. And when we sent it to Science, when it was rejected, went to PNAS and so on, it was rejected everywhere. Then I knew we were up to something really important. And that is a lesson for you. I mean, of course, it can be complete garbage, but, but we were convinced this wasn't garbage. And now it has developed into an entire field, really. So the dynamics of the atmosphere is also being changed. Thermodynamics, fine, of course, the planet gets warmer, you have more often statistical terms, heat waves. But the really important thing and the really risky thing is if the circulation patterns of the atmosphere change. And the jet stream clearly is prone for big changes. So this is actually one of the, and so we did a paper just last year about the Alberta wildfires, the costliest disaster in Canadian history, big wildfires. And this had to do with this planetary wave dynamics. And it's like quantum mechanics. These waves have to go around the planet, and you can have a 4 wave, so to speak, a 7 wave. So how many troughs and crests you have. This was the wave number 4, which was particularly deadly. And this is a completely different explanation. When if you ask the ordinary forest manager, when he says, oh yeah, there's too much litter or whatever, or somebody was not careful in treating a fire. But no, this has to do with a change in the atmospheric pattern. Now, This is the map I created a long time ago. Actually, I first presented it in the other place, namely in Oxford, at it was a Lineker lecture. It was just a cartoon, but it has turned into a really serious map. You could call it something like the physiology of the climate system. And these are the vital organs, if you like. So you see the jet stream. Where are the big ecosystems like the Amazon rainforest, the tropical coral reefs, of course, the big ice sheet. And you have these oscillation patterns, El Nino southern oscillation. You have the summer monsoon, the Indian summer monsoon. Maybe even more important in the future will be the West African monsoon, because the precipitation patterns of Africa will change dramatically. Ironically, at the Horn of Africa, you know, Somalia and so on, we will have more precipitation probably, but there will be less precipitation clearly in the western part of Africa, which will completely change the food production systems and will have major societal impacts clearly. So you see the jet stream here, and there is clearly another very important circulation, not in the atmosphere, but in the oceans, that is the Atlantic, North Atlantic system, where the Gulf Stream is part of it, which is very important for the British Isles, of course, because the benign weather we have here at a latitude which is otherwise shared by Alaska has clearly to do with west-east transport of tremendous amounts of heat by the Gulf Stream, and that is also going to change. So this is, if you like, the map of the vital organs of the planet, and the idea was originally climate change is on the one hand a gradual thing, but at the same time it comes in disruptive steps really. It is like you heat up the human body, and when certain organs will collapse, maybe the kidney first or whatever, finally the heart. And this is precisely what happens here. So it comes in steps, and the question is, at what level of global warming are we still sort of safe of these type of disruptive things? And I've dedicated at least 15 years of my research to that, and some of the results I can show you. We do know, of course, that Greenland ice sheet will melt down irreversibly after a certain tipping point has been crossed. The best speculation right now, it's a sort of 1.6 degrees. In the end, it will be something else, but it could definitely be close to 2 degrees warming. And when you know, of course, once it starts, because the ice sheet is about 2,000 meters thick at least. So if it melts from the surface when it comes to lower altitude, so it gets into warmer air, and then it gets amplified. So it's a typical positive feedback loop. Also, the surface gets coarser, it's absorbing more radiation and so on. So once you start that, you cannot stop it anymore. It can take thousands of years, but it is completely irreversible. But we don't know yet whether we will reach the tipping point soon, and of course it's all non-linear, Greenland, whatever. This is the Gulf Stream system, and it's a paper done by a young student of ours at PIC, together with Stefan Rahmstorf, who is one of the world-leading oceanographers. And what it shows is actually that in the last 3 decades or so on, the Gulf Stream system has lost strength, 15% already. And there's an independent study, which was also published in the same issue of Nature, that comes to precisely the same conclusion, a completely different approach. This is a sort of fingerprint method. You see, you have strong warming off the coast of the United States and Canada. This is the redistribution of heat in the ocean. So this is like a smoking gun for us, and this smoking gun was discovered. But the other study came up with a completely different methodology. But we clearly see there is a weakening of the Gulf Stream already. Now, if you put together the jet stream modification and the Gulf Stream modification, this has a clear impact on the weather in Europe. Because in general, people think, well, global warming, yes, very bad for the Maldives and very bad for South Africa and whatever. No, this will impinge on our very life support systems, on our agriculture, on our tourism, on our coastlines and so on. So I skip this, and this is in a way one of my master slides, also for tonight. You know, in every talk there is a moment when you have to get it or you could leave. The moment is now. So watch out. And if somebody has fallen asleep, meanwhile, you know, give a little help. It's a busy map and slide, but it tells you the full story of tipping points and why we should actually have adopted, indeed, the targets from the Paris Agreement. You know, Paris Agreement says, try to keep global warming well below 2 degrees. Try at least as an aspirational thing to get it down to 1.5 degrees. This is telling you the full story. I mean, here are arrow bars, and they will be narrowed, of course, in the future, but the philosophies will stay the same. So here, this is the timeline. You see, we go back minus 20,000 years, actually 22,000 years. This was in the midst of the last ice age. And on the vertical axis left, you have the global mean temperature. So in the middle of the last ice age, at the minimum, global mean temperature was just a little bit more than 3 degrees cooler when in pre-industrial times. So it's a small difference, really. When we emerged from the ice age 11,000 years ago into the Holocene, that is this line here, where the climate was exceptionally stable, really. Yeah? So this was the basis for developing our civilization. And here on the right-hand side, you have the various scenarios. So in the best of all worlds, we would keep global warming below 1.5 degrees. The bar here, the horizontal bar, that's the Paris range. But unfortunately, we are on the red scenario here on the right-hand side, which will lift us to something like 8 degrees warming above pre-industrial by the year 2500. And here comes now the clue, because we have in the form of arrow bars, we have now marked here and sort of organs be tipped into a new mode of operation or maybe even into collapse. So you have on the left-hand side the Western Arctic ice sheet, and I'll comment on it in a second, the Greenland ice sheet. If the color turns red, we are absolutely sure, 97%, something like that, but the system will be tipped. So, and you see very sadly that we are pretty sure that the coral reefs, the tropical coral reefs, will be lost above 1.5 degrees already. Yeah? And certainly 90 or 95% of them will be gone with 2 degrees warming. The Western Arctic ice sheet starts in this light yellow and goes up to 6 degrees. That means some of the parts of the Western Arctic ice sheet have already passed the tipping point. We are pretty sure. But other parts are still stable. So it's a very inhomogeneous landscape. Greenland is much more homogeneous here. So you see Greenland when Arctic summer sea ice clearly. But what you see first is, the first message is, even if we hold the Paris line, we will probably have some disruptive changes in the climate machinery. And it will be very hard to digest it. But still it's a firewall against much more drastic changes which are above that line, so at 4 degrees warming or 6 or 8 degrees warming. So it's still worth to implement the Paris Agreement, but we will not get away actually without any major impacts. It's too late for that. If policymakers worldwide would have seen such a map 30 years ago and would have implemented the right sort of climate action, we could easily have stayed below the Paris range. That is too late now, but we will talk about it a little bit down the line. So, unfortunately, this is not the full story. In this philosophy and in worldview, you see you can calculate how much cumulative emissions are allowed in order to keep global warming below 2 degrees or 3 degrees and so on. And this is a very mechanistic worldview in the sense, okay, give me 500 billion tons of CO2 and I will push the climate system in temperature space by, say, 3 degrees or 2 degrees. But it assumes that the system will then stay put there. You can safely park it at 2 degrees. This is, in general, not the case in a complex system. So we looked actually also at the interactions between the various tipping points, and you can identify 14 different cascades, and each of them more or less amplify the warming. So if you would push in a Gedanken experiment, in a thought experiment, the system by 2 degrees according to the budget, the emissions budget, then Jim Lovelock, who is celebrating his 100th birthday this year, we talked about it. He came up with the Gaia hypothesis, a long time ago, where the system would, in a way, change the context so that you would roll back the system to equilibrium. That is the positive response of the context. If the context strikes back, then this would be the positive outcome. It can be precisely the other way around. The context amplifies the perturbation, the excursion. And unfortunately, what we see in our data and in our equations is not the Lovelock, the Gaia behavior of the Earth system, but you could call it the anti-Gaia behavior. That means the perturbation is amplified. I hope I'm wrong, actually, because, we all depend on that, and in particular our children, but unfortunately, so far, we have only seen positive feedback loops. That means that, let me go back here, excuse me. So, this is the big Odyssey, if you like, in climate space here. So you have the glacial, interglacial cycles. And here, the small loop would mean, okay, we go up to 2 degrees, and then the system somehow will settle back to equilibrium. But what if this big excursion could happen? What we call the hothouse Earth. And we published this paper in PNAS last August and made a big splash across the planet. So it was cover story even in US Today and things, and other highly qualified scientific papers, journals. But it made a huge splash, actually in Germany, even because the German word for hothouse is Heißzeit, which we used in a press release, became the word of the year. So, which is important in a way, because you see, you catch the attention. And in that paper, actually, we argued that we don't know, but there is a concrete possibility, a finite probability, that if you push the Earth somewhere beyond 2 degrees, 2.2, 2.3, something, you may just put it on a slippery slope and it will just slide into a hotter climate. And may stop only at 5 degrees or something. Again, this is not the likely outcome, at least from what I know tonight, but it cannot be excluded. So you see the risk, it's an existential risk, and the risk analysis has to be widened, actually. And in a way, this means we did in this paper also, so it means the current situation, the mid-Holocene, you had just 0.6 degrees warmer than pre-industrial. In the Eemian, it was, so that means 125,000 years ago, the CO2 was 280 to 300, maybe slightly higher than in pre-industrial times, and the Earth was by 1 to 1.5 degrees warmer. Sea level was probably higher by 6 to 9 meters, even in the Eemian, which is a benign interglacial. But actually, the choice now, under business as usual, is simply whether one of these two options will play out. One is pushing the Earth back 3 to 4 million years into the mid-Pliocene. And when you would have 400 to 450 ppm CO2, which we have reached already, 410 now, the Earth would somehow settle at 2 to 3 degrees warming. Sea level would only be 10 to 22 meters higher, only. Or, which is unfortunately now the projection, because look here, that's really important, 300 to 500 ppm. We do not know it more precisely because of the geological data, but we are working on that. It's more likely that we push it back by 15 million years ago into the mid-Miocene, where the Earth was actually warmer by up to 5 degrees, and 60 meter sea level rise cannot be excluded. Actually, the last slide, and that's another really important one. This is work by Burke et al., also published in PNAS last year. This is comparing now really in full geological time what we are heading for, and it compares it to the big changes in the Earth system over the last 60 million years ago. And actually, when you go here, so here the Earth was more or less ice-free. So the Antarctic ice sheet did not form yet. That has to do with the tectonic behaviors, or the Indian sort of plate crashed into the Asian continent and so on. But when you see a cooling, you know, this is 60 to 20 million years ago, when you have a finer time scale, 5 to 1 million years ago, who entered 3 million years ago, the so-called Quaternary, that is the glacial cycle, which is a very weird behavior of a climate system, because you go in and out in a quasi-periodic way into glaciation. And this is a fantastic and exciting dynamics in terms of complex systems. It's very unusual. And when you see how it goes up and down, and here is the Holocene, and that is the prediction now of the various scenarios. And you see, if we would follow really the business as usual, we would push the Earth even back 60 million years ago in time to an ice-free planet. And unfortunately, this is something that cannot be excluded. The big difference is it would happen, or it would be instigated in just 2 centuries. So this move by 60 million years would happen in just no time, actually. Yeah? And that is an amazing perturbation of a natural system. Now, if people think, well, this may never happen, well, I can simply tell you, we had another paper in Nature, Andrei Ganopolsky, Ricardo Winkelmann, myself, which more or less shows how previous ice ages started. So it was the initiating of an ice age. So you go back 800,000 years in time. We have all the data on that. And you can calculate a critical function that consists of just 2 informations. One is the insolation, which we can calculate, you know, the orbital parameters, so the tilt of the Earth axis and so on, when we can calculate the radiation. No, it's pure physics, it's gravitational physics. And then sort of radiation physics. And the other thing is the CO2 content, because of the greenhouse effect. So it's the function, a very simple function up there. And it simply tells you that this is the critical, in black, that's the critical CO2 concentration. Below that, you have the inception of an ice age. And the blue line is the actual data, which we can reconstruct. And when you see, whenever the blue line, the real CO2 in the atmosphere, is crossing the critical CO2 concentration from the left, when you have an ice age. If you are already in an ice age, of course, there cannot be another ice age. So it's really important, the path dependence. And when you count the numbers when this crossing from the left happens, it's 1, 2, 3, 4, 5, 10 times. And this is precisely predicting, reconstructing when the ice age started. So it's a very, very compelling finding. And the question is, of course, what will happen in the future? So we extend this calculation. And if you forget about these colored lines for the time being, recall when there is a crossing of the blue line with the black line from the left, there is another ice age. So it would happen in 50,000 years from now, and again some 100,000 years from now. But this line is the CO2 content without the human perturbation. So if you go to this line, that is what is already in the atmosphere, and it stays there for 20,000 years in the system. Or if you go to the red line, the dark red line, which is the business as usual scenario, when you see the lines do not cross anymore. So that means there will be no ice ages. We have already suppressed the ice age cycle, this glacial cycle. This is a fact, more or less. And it simply demonstrates you how deeply we intervene in the Earth system. I mean, tell any politician about that, they wouldn't simply believe you. Of course, they wouldn't understand it, and then they wouldn't believe you. But it's such a deep intervention which has already happened. This is beyond the tipping point already. We are beyond the tipping point of the glacial cycle already. And there can be much bigger interventions, of course, in the future. So you see, it's really an existential threat. So based on that, this was the title of my talk at the Munich Security Conference. And you know, we have people in the room, so senators from the US and the Prime Minister of Bangladesh, and on a panel, is this how our civilization ends? And yeah, that's a possibility. So in order to be practical, I try to show them what they can understand. And what everybody can understand is sea level rise. Because if we go back to an ice-free planet, we have some 70 meters sea level. And when you can see what happens to the Netherlands, they simply disappear completely. East Anglia will disappear. Cambridge will be in the water. But what is also interesting is, you know, we had there, of course, people who talked about the Ukraine conflict and the Crimean sort of peninsula. But look what happens to the Crimean Peninsula under this scenario. I mean, it becomes a small island, actually, and its strategic importance is much diminished, actually. So Europe will have quite severe impacts. Actually, I'm showing you that because you have seen figures like that. This is from National Geographic, I think 2013, right? We have seen these maps before, and at that time they were seen as scaremongering, alarmist, and so on, a thought experiment. But now, with what I have told you before, we think this is a real possibility to happen. And if you talk about, you know, armies and guns and warheads and so on, and talk about security, what is an army for? For either defending your territory or for invading other countries' territory. That is the only reason for why you have an army. But what if the territory is just vanished? So the geostrategic and the geo-military situation will completely change. So next thing was, this was for the American senators. So you see what will happen to Florida and large parts of Texas. Of course, this is well known, these reconstructions. But the whole East Coast would go. And finally, which is probably the worst of all, is what happens to Southeast Asia. And there you can pick any capital, so Jakarta, Kuala Lumpur, Bangkok, whatever, they will all be gone, actually, because of that. And however, whatever number of battleships you build, this will not ensure human security if this happens to our planet. And of course, when you can look at migration roads, we did this for the Asian Development Bank. So what are the likely migration patterns actually out of Bangladesh, out of the Philippines, and so on? And some of you may have seen this is a quite disturbing paper which was published in Nature Climate Change by Mora et al. In 2017. This was about the so-called wet bulb temperature. This means you do a combination of humidity, air humidity, and sort of air temperature, and you simply ask what is the physiological limit when your body will just collapse. So in principle, you would stand naked in the wide open, and there would be a lot of ventilation, and you would pour water over your head all the time. This is the wet bulb temperature, which would then be established. And here it is calculated how many days of the year. If it's full red, it means all year round. How many days of the year would you have, even under these ideal conditions of ventilation and so on and humidity, would you have a day where you cannot physiologically survive outside an air-conditioned room? And if you look here in the business as usual scenario, all the tropics actually will all year round have physiological conditions you cannot survive. So if you put it together with sea level rise, then it's absolutely clear that a lot of migration will have to happen, even under 2 degrees, and I'll come to that point a little bit later. So we are in trouble because instead of reducing emissions, we keep on pushing them upwards. So we had a little bit of hope after Paris 2015 that the emission curves becomes flat, and maybe there is even a sort of peaking, but this has been thwarted by the new data. So the CO2 emissions and the emissions of methane and so on go on. Maybe interesting, a colleague of mine, Malte Mainshausen, and others did this very nice assessment. Which country, according to its national action plan or non-action plan, is contributing what in terms of global mean temperature? And this is really interesting. You see here the contributions. So in green, it's 1.5, and 5 is dark red. You can pick your favorite country now. And what you see is that most countries actually are on the 5 degrees trajectory. Australia, Canada, and so on. Actually, Australia is on the 4 degrees. Canada is on Russia is on the 5 degrees, Saudi Arabia, and so on. Europe is in between, so 3 degrees or something. Germany and UK are here between 3 and 3.5. The only countries in the world who are on a climate-friendly trajectory are those who will suffer most from climate change. Sub-Saharan Africa, you know, small island states in the Pacific. That's the irony of the problem, that precisely those who have contributed least to the problem will be punished most. And we cannot just fool ourselves and lull ourselves in a false sense of responsibility. Most of the industrialized countries are on a path that will lead us into the dark red here, clearly. So, what can be done about it? Now, we published a paper in Science some time ago, together with my successor at the Potsdam Institute, Johan Rockström, Malte Mainshausen, myself, Roadmap for Rapid Decarbonization. And the idea is that we really came up in 5-year step. So if this would be a 5-year plan scheme of the Communist Party of China, I do know the guys who write these 5-year plans. These are very clever people. But let's assume we have one party, probably not the Tories, who run the world. And we come up with a sequence of 5-year plan what to do. So we really spelled out precisely when do you have to actually get rid of the combustion engine for individual cars. When do you have to have the complete coal phase out, and so on? When do you have switched from industrial agriculture to sort of circular agriculture, things like that. So you can come up with that. Of course, this is a dream, but it's a dream supported by a number of facts. And in the end, so we came up with what you might call a carbon law, really, that it's a very simple rule of thumb, but it's important. You all know Moore's law, that the capacity of transistors and computer sort of hardware is doubling in capacity every 2 to 3 years. And in a similar way, we are talking about a carbon law that means you cut in half every decade the carbon dioxide emissions. By the way, why is the Moore's law really working? Because it seems to work already for 6 decades now. Because it's a self-fulfilling prophecy. Yeah? Because if somebody says, well, here's Moore's law, so if we wait for 3 years, I will get for the same amount of money twice the capacity from my computer sort of factory or store, whatever company. And this is an expectation you formulate. So the computer companies have to deliver on that. And then, if they deliver, they will be beaten again by Moore's law. So it's a self-fulfilling thing. The question is, can we instigate a self-fulfilling carbon law where we assume, yes, this is what will happen, and then the markets will actually have a wager on that. So investment dynamics will actually be based on this self-fulfilling prophecy. That would be the clue here, and that would be the trick. But in terms of power production, let me see, okay, we go back here. I mean, with solar, for example, and these are new technologies, often floating solar panels and so on, or you have the solar farm in Morocco, you have train tunnels in Holland, which are completely covered with solar cells. There are so many innovation options now. And it was all triggered by Germany with this feed-in tariff law, long time ago. Why did it work and why did it happen? Because nobody took it seriously. I know precisely the people who wrote this law and proposed it. And it was a small niche, really, in legal space. And nobody took it seriously. People thought maybe 50,000 people will subscribe to this. But very soon it was 5 million people. So it took off. The Chinese tried to conquer the market with heavy subsidies, which destroyed the German solar industry, of course. But, the costs came down dramatically in an exponential way. And now you can clearly envisage that by 2040 or something, we can produce all the electricity we need on this planet by solar gadgets. Now, in contradistinction to that, this is the most stupid figure that was ever created in the world of energy. And some of you may have seen it. This is the projection of the IEA, the International Energy Agency, based in Paris. And this is the prediction. So where are the famous world energy outlooks? So you see 2002 and so on. And this is the prediction here in 2002, the prediction of capacity added till the year 2030. So it looks like a Christmas tree, actually, because it always stays flat based on their calculations. And in black, it's the real development. So you see, how can you get it so wrong, really? Because you want to get it wrong. I will not elaborate on that, but in fact, we have an explosion. So I think the energy problem is easily to be solved. So there's a paper we did and published in Nature Energy. I can demonstrate on average the capacity grows with 23% per year, which is much more than what happened in the Industrial Revolution. In the Industrial Revolution, you had growth of GDP on average of 150 years of 1.6%. That is not much. But the textile industry grew by 6% per year, starting from Lancashire here. And that was quite dramatic. But this type of sector is growing at 23%. So clearly there is hope here. The problem is the following. In this line, this reduction of emissions, the black line above, was you assume that the biosphere carbon sinks get strengthened because these are our best friends. The ocean, but also the biosphere in particular, is soaking up a lot of our emissions, at least 50% altogether. So what are we doing? We are killing our best friends because deforestation is precisely producing the other effect. So you see, the decarbonization can only work and the Paris Accord can only be implemented if we both reduce emissions dramatically according to the carbon law and keep the carbon sinks alive. We should even strengthen them. New wetlands, peat bogs, and so on. What are we doing? We are killing precisely this other walk on which we are leg on which we are walking here. So it's absolutely crazy. Yeah? So this is a suicide strategy, clearly. So you see, it's not only this technical thing, but you replace fossil fuels by solar, wind, and so on. You switch to a new type of agriculture. You get rid of the combustion engine, and so on. No, the real precondition for stabilizing the climate is that we keep the natural carbon sinks alive. Without that, it's completely lost. So what is going on in Brazil now, you know, with Bolsonaro and so on, who just wants to open the Amazon rainforest for the markets, that could be really the death sentence, actually, to the climate system. And so there's a map where you see the destruction in Africa, everywhere. And probably you have also seen this was hitting the front pages of the journals, that we have this all but collapse of the insects on this planet, so 2.5% per year. And this is precisely what you need for the healthy carbon sinks, of course. So this comes, and this has nothing to do with fossil fuels. It has to do with industrial agriculture, at least in the developed countries. So there was this thing that ecologists went back to Puerto Rico 25 years after their first experiences, and they took a Land Rover and were driving into the jungle, and suddenly they said, something is wrong here, something is wrong here, what is it? And the jungle was completely silent, no birds singing. Why? Because all the insects had disappeared. And so the birds who feed on the insects also disappeared. So you can see it already happening. So this is the other big front here, namely keeping the natural carbon sinks alive. So what can we do? Now, I was actually chaired a panel for the European Commission, Decarbonization Pathways for Europe. So that's the group of people. So Commissioner Moedas and myself, we had, for example, Paul Ekins from University College London, so well-known economist, and Maria van der Hoeven, who formerly ran the IEA. So, of course, I showed her this really stupid figure, and she said, I have nothing to do with it. Okay, what can she say? But she was the Minister for Economic Affairs in the Netherlands, a very clever person. So we came up with this idea, which will be explored. You know that the next budget for Horizon Europe, starting 2020, will be about 100 billion euro, and 35% of it are earmarked for just climate and energy projects. So 35 billion euro is a lot of money, actually. Yeah? Unfortunately, the UK will not participate anymore. Hopefully, yes, but in a no-deal, crash-out scenario, yes, you would actually, because the UK scientists have always been the most successful in tapping the Horizon programs, the FP5, 6, and so on. So it's just shooting yourself in the leg here. But one idea would be that, we need transformation soon. We need it now. And it has to be systemic innovation. The idea was that you pick regions big enough to have some self-containment and small enough to still be managed, where you include actually and put together in an integrated way all the innovations for decarbonization. We call them transition super labs. And we hope this will be part of Horizon Europe, and it will be projects which will be funded by billions, actually. So you could pick, say, the Black Country, Birmingham, the north of England, Rotterdam region, or here in Germany. So I go forward. So we have 3 lignite coal regions still in Germany, and they produce the biggest pollution in Europe. So a very interesting social experiment was done in Germany. The government had promised, Germany is phasing out nuclear. By the end of 2022, we will be completely nuclear energy free. And of course, you could argue this is foolish or this is good, whatever, it will happen. But at the same time, we also want to phase out coal. And this is quite a challenge, because in the UK, you have more or less phased out coal, but you still want to apply heavy subsidies to Hinkley Point C and so on. But I will not talk any more about it. But Germany needs to phase out coal as well. So hard coal is more or less gone down, but the lignite coal, open pit lignite coal. And the government was not able, and that is an interesting lesson, I guess, to come up with a phase-out plan. Because you have so many vested interests against each other. The trade unions, the jobs, the energy prices for the heavy industry, and so on. Regional growth or GDP, education, infrastructure, everything. So what did they do? They established a commission, civil society commission, no sitting politician involved. These 28 people, actually including myself, I was the only climate scientist, and they asked us to come up with a phase-out plan. Whatever it costs, actually it will cost 150 billion euro, so it will be very expensive. And we came up with a result. Actually, the last session took 21 hours, the longest session I ever had, without breaks. So it really started 8 o'clock in the morning on a Friday and ended 5 o'clock next morning on Saturday. But we came up with a compromise. And of course, we could go through that. So there is clearly, for even sharply defined from coal power stations and so on, when they will be taken off grid and so on. And the affected states will be compensated by 40 billion. There will be extensive measures for employees. There will be subsidies for electricity price rise and so on. So it's a master plan, if you like. And the question is now whether it will be adopted, and optionally coal use would end in 2035. From a point of view of climate, this is much too late, of course. So we opted for 2030 at the latest. But you see, we hope that the markets will simply respond in the right way. Because once you have a sunset year, who will invest really in coal power? And we hope that divestment will simply happen. There will be no education in this sector anymore and so on. So we hope the system will collapse much earlier. This is a civil society experiment now. And if this format proves useful and successful, could be adopted for other sectors, but maybe also for other countries, really. And we could only do it because Chancellor Angela Merkel, she's a physicist like myself, and I've advised her for more than 20 years now. She was fully supporting that, and whenever the whole system seemed to collapse, she tried to bring together the people. So watch out what will happen in Germany. We will meet again in 2038 here. Probably not me, but some of you. But given Jim Lovelock turning 100, I think there is a fair chance to reunite then. And, but I think we are on the right track right now. It's a fascinating civil society experiment. Maybe this could be adopted by other countries and regions. So let me end with a few what I call subversive innovations. Because if we want to transform the world, it can only be done in a subversive way. Because if you say, this is to replace the steel industry, then of course they will use everything. They will use their propaganda machinery, their lobbyism and so on, and will make sure that this will not fly. So you have to bring up things which nobody expects or nobody takes serious, like the feed-in tariff, as I told you, which nobody took seriously. But when it became so big that you could not crush it anymore. Now here's a very interesting thing. If you think you have a certain carbon budget, say 500 to 700 billion tons of CO2 equivalent, to stay below 2 degrees, then you can look how much of that budget would be consumed just by building new houses in the future, in China, in Africa, anywhere. And actually it's already 60%. But there is a way out of that, and actually it would even be beneficial for the climate. Namely, you build all new houses, even big ones, from wood. And this can be done. There has been tremendous progress in, say, cross-laminated timber techniques and things like that. This is more elastic than concrete and steel. It's fireproof. It is earthquake-proof, and so on. You can even make the wood translucent. So it's fantastic technology. You can use carbon fiber to compose it with, and so on. But the funny thing is that this would not only avoid the emissions from producing cement and concrete, but it would suck up carbon, because this is the budget. Take the second bar only. The budget left for roughly 2 degrees, so 2017 to 2050. This is what would be eaten up by mineral-based materials alone for construction. But if we would switch to mass timber, then only the yellow bar would come up. So that means you can actually, by growing the trees, you can actually extract a lot of carbon from the atmosphere. That is the natural way of geoengineering. And if you don't burn the wood, but you store it in buildings, which can last for hundreds and hundreds of years, it's safely tucked away. So we can construct ourselves, build ourselves out of the climate crisis. It's not the full story, but it's a very important one. So we have just a paper in Nature under review where we actually corroborate all the numbers and support them with our analysis. So it's a really interesting option. Another one is financial sort of opportunities. So on the one hand, in this world after the financial crisis in 2007, I mean, the world is awash with capital, which is looking for safe harbors. But you don't get any return on your investment, at least not in the usual products. So the rate, interest rate is very low. On the other hand, we need to transform the entire climate system, the entire energy system. So why do these two things not come together? So we came up with an idea for the German government that a sort of transformation, public transformation fund needs to be set up, like the sovereign wealth fund you have in Norway. But how do you feed it? And that's the interesting point. I mean, if you go to Fortune 500, the list of the richest companies in the world, and you look what business do they pursue when it's all oil, transport, manufacturing based on fossil fuel. So all the big fortunes in this planet, on this planet, have a huge carbon footprint, actually. They actually you have a direct relationship between the fortune, say 20 billions, and the cumulative carbon emissions, which were used for doing it. So we proposed that a special inheritance tax should be developed. So when the owner of such a fortune dies, you could naturally sort of pay back to the future by setting a certain interest rate, a certain tax rate here, and feed it into a transformation fund. And we have just played with it. If you would only do it for the super rich, 5% or something. So paying back the externality, which was never compensated. Because most of his companies got so rich because they never had to compensate for the externalities to the atmosphere. So if you would just take a little bit back of that, it would actually provide you with hundreds of billions of euro, and this could be invested, also as public-private partnerships, into innovative enterprises. And I just cannot help to allude to this story here. You know, when people say it's impossible to save the planet based on ethical principles, because real politics will not allow for that, well, excuse me, it happened several times, but you had precisely this type of societal transformation based on ethical principles. For example, the abolition movement here in the UK, and this started with a few people only who met in London, and in the end turned into a social movement which was so powerful that finally even the people at Whitehall had to pass a law in 1833. But what is not known, or by very few people, is that the slave owners were heavily compensated. So it is like what we do with the coal phase out in Germany. We heavily compensate the owners of the lignite pits and so on. So 40% of the British treasury was spent on compensating the slave owners. One of them was the family of David Cameron. And actually, I think about 20% of the current sort of rich families in Britain benefited from that scheme. So it is the compensation for a deeply unethical business, so to speak, which is still keeping the elite in this country afloat. That's an interesting insight. So you can go back to the original source here. So finally, I told you that if in a world which is 2 degrees warmer than today, or when pre-industrial, it's already 1 degree, there will be massive migration. And of course, if you talk about it, what do natural systems do? If it gets warmer, they are moving polewards or uphill, things like that. And of course, there's no police who sends them back, the birds or the fish and whatever. It's impossible to think. It's a natural adaptation. These are actually economic refugees. Why? Because we are going for their food, for livelihood. So it would be absurd to think that you would have a police everywhere to send back all the animals and the plants and the ecosystem. But for human beings, we are doing precisely that. That is the crazy thing. So we thought what could be done about that, and we came up with a really provocative scheme. And I presented part of it in Katowice during the COP. Migration will happen in a warmer world because of sea level rise, because of melting glaciers, because of droughts, because of hypothermia, as I've shown you. The question is, will this migration be managed top-down or bottom-up? Top-down is the Stalinistic way, for example. You move millions in space, and this will end up in a disaster, of course. There's no human dignity or you empower individuals to move where they find a livelihood, like the animals, the fish, which move northward in the North Sea, for example. And the only way to do is to give them something like a passport, which allows them to enter all those countries who are responsible for their predicament. So we even calculated, so if you have more than 2% of the global cumulative emissions, you have to actually hand out a climate passport to those countries who need it. And of course that sounds completely crazy in the beginning, but if you sit on the Maldives, you know your territory will be gone. There will be no national state anymore. And Tuvalu or Bangladesh, I showed you. So you see, we either empower individuals to move and to migrate in dignity through such a passport, or actually we try to come up with a top-down scheme, and this will end in complete chaos. And there is actually a historical precedent for that, and otherwise I wouldn't have brought it up. So this is Fridtjof Nansen, the godfather of polar research. A very handsome man, as you can see. But he was also awarded the Peace Nobel Prize in 1923 because he invented a so-called Nansen passport. And you may have heard about the Nansen Initiative on migration. And this was precisely the idea because of the First World War and the breakdown of the conservative monarchy in Russia, for example. So many people lost their national identity, they were exiled by Lenin, for example. Millions and millions. So Nansen came up with this idea that those people who have lost their nationality will be granted an international passport, which allows them to move. And actually more than 50 countries accepted that. This was a miserable document. You were treated as a second or third-rate citizen, of course, but nevertheless, it allowed many people to save their lives, including Igor Stravinsky, for example, or Marc Chagall. So in this existential crisis we are in, why not thinking about an international document, a climate passport, which allow those people who have contributed least to the destruction of their home to enter the homes of those who have contributed most to this destruction. It only sounds logical. Now, of course, there is a trick here in this argument. I'm sure Donald Trump will not like this proposal. But you see, just the expectation that this could happen could make people think about strengthening their mitigation efforts, for example, to avoid it. For them, it's the worst thing that can happen. And Brexit is just a precursor of this type of thinking. So free movement of people, my God, the worst thing on earth. Homo sapiens actually came from out of Africa and went a long, long way until reaching the British Isles. Just think of it. Anyway, so Fridtjof Nansen is a really interesting person. So I end now with this slide here. Actually, and then Martin Rees will come full stage. Now, you know, at the Munich Security Conference, I was attending also this speech by Mike Pence. And once you have really listened to that man, you go home and pray for the life of Donald Trump. You know what I mean, huh? Because this man is very clear in his head. He has a clear agenda. He's completely self-righteous. He would create the new kingdom of God on earth, starting in the United States. He's very dangerous. Donald Trump is an idiot. Yeah, sure. But he has some human traits sometimes. But Mike Pence would be really dangerous. I know this is live stream, so let's see what the consequences will be for me. Yeah, you never know. But I dare to say this is a really dangerous man. And this is the one side of the coin of humanity, if you like. So it's all about power. He simply said, if you do what the United States expect from you, we will be your partners. Huh? Well, before Angela Merkel gave a speech and was sort of made a sort of passionate plea for multilateralism again. But Mike Pence simply said, this is American rule, you do what we want you to do, and when you will be fine. And at the same time, and that's the other face of humanity, where I think a lot of inspiration can be drawn, that is the school kids strikes, or the Extinction Rebellion people and so on. Yes, I fully support you. And because this type, it reminds me clearly on the times in the 1960s, the civil sort of type of blockage of things which were related to the Vietnam War and things like that. But we are in an existential crisis. It is far going beyond what the Vietnam War defined, for example, far beyond that. And it is the future of the young people which is stolen from them by those who, are complacent, saturated, and so on. So I think the question is, who will win? The person on the left or the persons on the right in the future? We have enough scientific evidence to conclude that these should win. We have enough. But in the end, this will be decided not by good political action and it not be by more science. It will be decided who has the better narrative of modernity, which is not just the long shadow of the Industrial Revolution, but it is a modernity which is inclusive, which is sustainable, and which is fair. And for the sake of these young people, we have to tell this narrative, and we have to develop it together. Now, you have the young people, Greta Thunberg from Sweden, the Extinction Rebellion people, and so on. I hope this will become a really powerful social movement across the planet. But in times of despair, you often get very unexpected allies. By the way, Dante Alighieri said, the hottest place in hell is reserved for those who in times of deep moral crisis stay strictly neutral. And this is already sort of relating this to an unexpected ally. And this is Pope Francis. So I show you the final picture here. Last November, clearly can see the Pope, but you also see Lord Martin Rees here, who is member of the Council of the Pontifical Academy. I'm sitting there in the second row. And this has turned into a really important academy, which was instrumental in the production of the encyclical Laudato Si in 2015, just before the Paris conference, but also in other aspects and respects. So you have many Nobel laureates there. It's in a way the most distinguished academy in the world, but it's also the one which is really guided by ethical principles. And so you see, if you have God on your side and youth on your side, you can only win. Thank you very much.
Schellnhuber, for your intriguing talk. I'm curious to hear from you what your estimate is. When can we expect the sea level rise you're describing? Is this hundreds or is this thousands of years? And do you think people will be able to abandon cities in a structured way? And how many years will they have to abandon the cities?
Yeah, I mean, something like 1 to 1.5 meter sea level rise is more or less to be expected by the end of this century, which would already create, together with storm surges, stronger hurricanes, real problems for many small island states, for example, and delta regions. The full melting of all the big ice sheets on this planet would take thousands of years, clearly. Yeah? The question is, of course, would we just move all the coastal population away from the coastlines in line with this development? And in principle, it can be done, of course, but who would dare to do this plan? I mean, to really define, this city has to go in 20 years, the next one has to go in 100 years, and so on. It is a tremendous challenge, of course, and unfortunately, it means it would have to break the trend we have right now. Right now, people are moving towards the coastal zones. We are moving towards the deserts, like Phoenix, Arizona, and we're moving uphill, actually. It is precisely where climate change will make the regions uninhabitable. And we still have population growth. So in a way, it's unfortunately the perfect storm, precisely in a time when you have most people on Earth and fertile land and so on is most needed, you would have to retract from it. And this is a very bad narrative, actually. But of course, I mean, if forced, people will abandon coastlines, starting at the coastline of East Anglia in Norfolk, which is already crumbling away. And later on, you will try to defend certain cities, which is already an ethical dilemma, of course. Which city will be defended? Which one will be abandoned, for example? But you can imagine that the social tensions would be tremendous for doing that. Ultimately, of course, instead of drowning, you move away. But a colleague of mine has just done a migration study. Thanks a lot. A migration study in Bangladesh. Yeah? And unfortunately, I asked for water, I got white wine. This is a miracle. Trinity College. But you see, she did a study on, migration. Some people even say there is no climate migration at all. Everything people do is looking for a better job, social security, and so on. But it happens all the time, really. So she really went to the slums of Dhaka and so on and asked people, why did you move? And it turned out that, yes, there was an extreme event, and suddenly your plot of land was just washed away, and half of your family drowned. So unfortunately, I don't think migration will happen in this managed way and retraction from the coastline, but in disruptive steps, so to speak. So people will cling to where they are as long as possible until you just get destroyed, actually. And so it sounds nice, we have a long-term adaptation plan. Actually, the only way would be that you empower people, give them full information on what is going to happen, give them the full right of moving freely, and even give them a global green card, if you like, that you can go for a job anywhere in the world. Then I think we could manage migration in response to the sea level rise. But this political situation has to be created first, and it's an enormous challenge.
Thank you. Do we want to go along the same row? Do you have the mic there?
Thank you very much. I want to ask about your views on solar geoengineering or solarization management. And I think you have been vocally criticizing these technologies. But I felt particularly when I read your paper on House, I sense you kind of changing your view about this technology. What do you think about this technology now?
Actually, in the Isaac Newton Institute, I organized the first geoengineering conference here in this country in 2003, I think it was, where later the Royal Society did a report. John Shepherd was the lead author. at that time, this was just, you know, a fairy tale in a way. So people from Los Alamos came, Edward Teller's cronies, and told us about solar radiation management and things like that. Now it is, of course, an option you have to really consider. And it comes in two parts, of course. So you have this solar radiation management, where you try to inject sulfur, for example, or even smarter stuff into the stratosphere in order to shade off the sunlight. And the other one would be artificial removal of carbon from the atmosphere. I would think with the current level of knowledge, I think it would be absolutely irresponsible to go into solar radiation management. But you can think about removing carbon from the atmosphere. But in my view, and I've done a lot of analysis on that, I think strengthening the natural carbon sinks is the best, the cheapest, and the safest way to do it. So instead of what Klaus Lackner would propose, construct millions of artificial trees, let's save the natural trees actually, and strengthen them. And the building a global carbon sink, you know, switching to wood construction, where bamboo, for example, would also play a big role, is the natural type of geoengineering I would go for. It may happen that, and my colleague and friend Paul Crutzen wrote a paper about that and argued, we might actually slide into a state of complete despair, but we do whatever is needed, so to speak. But I think we can still avoid it. That's the one argument. And the second is, what I learned from the big oil companies, for example, last week there was a meeting in Oslo about that. They actually think this is a reason for doing nothing, but we have up our sleeves, you know, geoengineering technologies. So in the IPCC report I showed you in the beginning, the 1.5, you have several scenarios, and one would have tremendous negative emissions, BECS and other things. And these companies simply argue, yes, we have the solution. We will do business as usual, we will improve energy efficiency, of course, but in the 2060s, 2070s, we will just remove immense amounts of carbon from the atmosphere, and we will be fine. And this is the real problem here, that you create a self-destroying prophecy here. So, of course, a scientist needs to look at all options. And of course, many of my colleagues argue you have to do the research at least, legal research, many other things. But I would say, first things first, that is preserve the natural carbon sinks, and last things last. And last thing of all is solar radiation management.
Thank you. This is one of the questions from the Twitter feed on the internet. And someone's obviously been watching our lectures in previous years with Kevin Anderson and asking about the role of climate experts in showing leadership on mitigation, and particularly about the question of whether you should fly or not. I wonder what you thought about that.
Yeah. So, actually, Kevin was a member of the Tyndall Center, and he's a bright man, sometimes a bit provocative, but I think this is absolutely warranted in the situation we are in. Now, Kevin argues in the following way, and we had it also in our precursor meeting conference before the Paris Agreement in 2015, so he was arguing like that. What he's saying is we are really in a emergency situation, clearly. We have to bring down global emissions. We have to peak them in the next 3 or 4 years and then to bring them down in an almost exponential way, while at the same time safeguarding the natural carbon sinks, even strengthening them by reforestation and other things, and restoring wetlands. So this is a tremendous dual challenge, clearly. So, of course, with what we do with the Coal Commission in Germany, with the renewable energies and so on, we can have systemic changes. But what Kevin is saying is, on the one hand, don't let yourself be fooled by the promise of tremendous negative emissions delivered later, and also do what you can do already now. And it's absolutely right that you can today, tonight, decide not to take a plane to the next vacation. Or you can decide not to eat meat anymore. Of course, I'm not preaching to you that you should do this or that, but the elasticity in terms of economics, of personal sort of choices and lifestyle changes is enormous, really. So you could do it overnight. And it's part of the equation. It's not the full equation, clearly. We need to have systemic change as well. But it's true that people, individuals, consumers, producers, whatever, prosumers, and so on, can make changes and choices overnight that really can save the planet. It is like that. So I actually, when I would have been asked the same question, or when I was asked 10, 15 years ago, I thought, this is so unpolitical. You talk about lifestyle. Come on, we talk about laws, about technologies, analysis, and so on. But now I think it's the most political question of all. How do you behave?
And I was interested in your response. You again mentioned this framing it as an emergency, and it's. I don't know if you've felt this personally. I've personally felt that how I've talked about this has gone from very rational and scientific to much more. We're in a crisis. We're in an emergency. Is that your experience over the years, and how does that go down with the people you're talking to, particularly the policymakers?
Yeah. On the one hand, I mean, if a house is already burning and you shout fire, is this irrational? I think this is very objective. It's an observation. And unfortunately, the house is on fire now. So this has nothing to do with alarmist or not alarmist or rational order. It is the sober analysis of the situation. And it's rather irrational to bet on tremendous geoengineering options. But there is, of course, a challenge for everybody who is a scientist with, the best practices we have adopted and learned and so on. Be objective and never become an advocate for whatever option. And this is really a challenge. I think most of my colleagues have now decided that this is a situation, if you know about the predicament, the challenge, you cannot be silent anymore. You have to speak up. And you have to call a crisis, and an emergency, and a cataclysmic, so to speak, perspective, a cataclysmic perspective. It is like that. I very much feel myself reminded, and Martin Rees knows about that, where the Nobel Laureates meeting in 2009 kicked off at the Royal Society, where I was referring to the Russell-Einstein Manifesto. I think it was published in 1955 in London. And, this was about the risk of destroying the entire planet by a nuclear shootout. And there were 11 people signing it, I think 10 of them Nobel laureates, including Einstein and Russell. And what they said is one paragraph, and you can't just copy it and just replace the word nuclear arms race by global warming. They said, those people who know most about the problem are the most gloomy. Is this irrational? No, it is precisely the bitter and deadly rationality we have found in our data.
Do we have any more questions? Yeah,
I can't help but notice you didn't mention anything about sort of population, which is a major issue, and particularly the areas which are most affected, say sub-Saharan Africa, are areas where population growth is going to be quite big.
Yeah, this is also an evergreen question, of course, but of course it needs to be asked. First, there is no ethical way, unlike deciding to stop flying, there's no ethical way to remove a few billion people from this planet. At least I don't know of any. And even a sort of one-child policy, where you can argue whether this is ethical, if you sort of prohibit people from having offspring, even that takes a long time until it plays out. So I don't think we have any strategy at hand, whether ethical or non-ethical, that could save the climate system based on demographic interventions. So that's the one thing. The second is that, who is producing the big emissions? And if you really look at the data, you find that it's the top billion on this planet, so the richest billion, just creating 80 to 90% of the emissions. It's not these poor fellahs in Egypt or fishermen in Indonesia who are responsible for the emissions. I showed you the map. It is the rich people. So we rather start where the problem is caused, actually. And the third thing is that, in a way, it's very cynical to ask the global south to refrain from having children because our own wealth is so big that the planet is being wrecked. Because if you look at the population density of Africa, for example, it's still much smaller than UK, for example, or the Netherlands, or France, or Germany. So I would say, if somebody has to reduce population, it is us.
Right. Should we have one final question here, and then we'll wrap it up?
Hi, thanks a lot. You mentioned Brexit obviously you're here, so in parallel to climate change. And I wonder if on your last point, well, the one before population, on the sort of we need to talk about the global interests. And if I were to draw a parallel with Brexit and talk, and how experts have been warning in the national interest, and in fact we see party politics rife in this country. Is that a UK-specific problem, or can we think about, how too much alarmism on climate change and how it doesn't fit into kind of normal politics of the day-to-day, how that impacts the action, I guess.
Yeah, you have an hour or so. This is a very deep question, and it is a very convoluted subject, of course. In a way, I think Brexit is a similar sort of populist reaction to a broken narrative like the Yellow Vests in France and Salvini's crowd in Italy and so on, and Bolsonaro it is that the dream of getting richer without any limits was broken with the financial crisis. And of course, at that time, also when I lived here in the UK, the idea was, or the expectation was, everybody will be a bit richer next year. Of course, the lower class is only 1%, but still. And so it doesn't matter whether the fat cats get richer by 10%. Now, after the financial crisis, this dream has been shattered. The rich really get richer every day and every night, but the lower middle class doesn't get anywhere, actually. And so that's what I mean with the narrative of modernity. This idea that you don't need to have any social justice because there's so much to distribute can only work in an inflationary universe, in an ever-expanding economy. But we have planetary boundaries, and when you come back to, we have to create wealth and prosperity in an inclusive way within planetary boundaries. That is the new challenge, and that is the new narrative you have to tell. And this cannot be solved by just expecting you know, growth rate of GDP 5% every year, and when you can discount the future with 6% per year, that means the future doesn't matter at all. This is economic nonsense, actually.
So I think on that note, we're going to wrap it up. I think it's been a great talk and a great panel. It's the first time I've ever done a panel discussion sitting underneath the Pope. And I hope
He's a nice man.
Yeah, I hope you'll join me in thanking Professor Schellnhuber for a fascinating and sobering talk. Thank you.